I'm very happy to have Hubertus von Zastrow from pro-micron here on stage. Herr von Zastrow, welcome to Darmstadt. Herr von Zastrow, Mr. von Zastrow is the managing partner from pro-micron, I think a well-known company for sensor integration and monitoring solutions. Today, in his keynote, he will speak about different use cases along the value chain. He will start with needs. He will give us some examples. And I know, since we are collaborating for a long time, always having new ideas. The boxes of good ideas is always full. Together we are heading towards Gaia X topics in the next steps. But today we will hear this presentation, and in the evening event you will see the products running at our Grob machine tool, where we can have a closer look. But first of all, Mr. von Zastrow, I'm excited about your keynote. The floor is yours.
Thank you very much, Professor Weigold. Thank you very much for all of you for coming here. And you know, I was so proud what this value chain together can achieve, even in difficult times during Corona. We operated together our third DMAP, digital machining marketplace. Obviously, PTW was part of it. And that way we managed to not only fill the gap within Corona, but actually do more and new things together and show them to our customers. And that's exactly what we are doing here as well. Autonomous 100% workpiece quality control in production. Autonomous driving, everybody knows. We think that's where it's going to go to, but with exciting opportunities for everyone in the value chain, including our workforce. So what do these three applications have in common? They all need perfect surface quality and position tolerances. It doesn't matter who you are, you want to be good. And yeah, that means they need perfect components. Whether it's the blisk, the form, or a very important part within the machine, for instance, the magazine of the tool holders. And how can we avoid this without just having to be next to the machine and hear it and see it? Manufacturers need to check every workpiece made. Or is every workpiece too expensive? Maybe only every 10th, or maybe only every so many workpieces. Or find out whether it all works at the end when you've put the entire systems together, and then you find out it doesn't fit, or it doesn't pass the quality control. It would be far too expensive to check every workpiece for most applications, not for all. What we want to do as pro-micron is to enable you to check the quality of every workpiece and act on any lessons that you're learning autonomously, so that it becomes the standard to do exactly this. How? How to save money and do more quality control. I hope that with this slide I'm boring you, because hopefully by now everybody knows Spike Polar can do exactly this. And that's one of the reasons that I got excited when I saw pro-micron. That's many years ago. So if one cutting edge is not perfect, we can see it while it's operating. And of course, you know much earlier that something isn't quite right than when the tool breaks or when it's produced bad output. So in a nutshell, if we use this new tool for a finishing process, or a used one, or a more used one where one of the cutting edges is broken, it's going to create less good surface qualities. That's nothing to do with us. What we can do, like I said or showed just now, is to demonstrate during production that things are happening. Forces are increasing, you can begin to see the wear, and when one cutting edge is broken, you also see which one and that it's happened in time, before the entire tool is broken. So you can automatically change your tool. To make sure that not just the process engineer can see it, but the machine can read it, we developed the spike KPIs. And you can see here, for instance, this is relatively symmetric. This is also relatively symmetric. This isn't symmetric. That's why this bar is going red. Whereas the normal force that we're measuring, in this case the bending moment, is going up, of course, from this stage to that state. But between here and there is virtually no difference, because it's only a machining, a finishing process that doesn't need much force. So force alone, without the algorithms of the spike polar, wouldn't tell us the whole story. So this can now be read by the machine. And of course, you need the connection to the machine to then initiate the relevant actions. Most of you, I hope, again, will have seen this before. But wouldn't it be helpful to combine things? To combine the spike measurement, you know, the torsion, the bending moment, the actual force, with the access data of the machine while producing. So you get a spike map. And if you have this spike map, the smart Bliss gets a nice colorful coat. You know exactly not only what is happening, but where on the workpiece it's happening. So let's say we've made our first blisk, and it looks perfect. Let's take it as a reference. And then turn that reference into a nice color. You could choose, if you want, the pro-micron color. So every good part that is made, if the spike map looks like this, you've got a good part. And that's where it is. If, however, it looked like that, you know, it might look like this. And that's what you don't want, and you want to know where it's not very good, and you want to know it as early as possible in the process. So you can maybe avoid ruining that workpiece, that expensive workpiece. So we're trying to make complicated technology extremely simple for those that use it. And I think it's easy to get the message that maybe this is where I need to do something. So we compared what would that spike map look like if you used the different data sources. We like using the current of the motor. Why not? If it's useful, why be more complicated? So we used our spike map with the motor current, with the torsion. And for that picture, part 1, which was a good part, we got this picture. Then we used it with our spike torsion. Any difference? We are much closer to the workpiece and don't measure side effects. And you can see it's beginning to be a little bit more like the spike mobile spike map using bending moment. So, of course, which one of these three, if I want to produce 100% autonomous workpiece control, quality control, would you use? Of course, it's a rhetorical question, I hope. I would suggest we use this one, because we see most. And if we use that one, if it's possible to use, then turn that into the blue ideal product, workpiece, and then compare, like we said before, what would happen. If you have less quality sensitive workpieces or processes within one workpiece, why not use the spike map with the motor current and then combine it with a spike mobile for those processes in the workpiece that really need to fit. Now we've talked about allocating bending moment, for example, onto the spike map. But you know, of course, if we've got bending moment, we can do much more with it. Let's look at our idea of the spike KPI. You can see here in blue, when the tool is new, we've got an asymmetry KPI, and it's at a very low level. That's good. There is very little asymmetry. As you get a more worn tool, the asymmetry KPI, from a percentage point of view, goes up. And here it becomes bad. So that's now not just using bending moment, but it's using an algorithm that uses the bending moment to define the symmetry and avoid chatter marks on the surface. Now, of course, we can use that, just like we use the bending moment, and apply it to the spike map in order to take the right decision. For instance, change a tool or change the process. Okay, I've got this bet with my guys in the sales team that the longer you don't talk about how we do it, but what we are doing, the better you are. What is the benefit? Let's not talk about the technology all the way, how we do it, but what is the benefit? I hope I was able to show the benefit of spike data, of the spike map, and this is how we implement it. We've got two versions. If you want it permanently in all machines, in your spindle, we have the integrated solution. And if you want to retrofit it and just use it for your very sensitive processes, we have the spike mobile, the tool holder version. And they all have the ability to, if you want to be really sensitive, even if you have the spike and spindle solution, because we can be more flexible and individual on the tool holder, you can combine the two. And that's, by the way, what companies like Roper and DMG would recommend you to do. So again, both of these, and that's the message of this slide, do exactly the same thing. They measure the bending moment. In this case, they measure on the spike polar, and they can use all the data algorithms that we have discussed before. And that's why spike polar, spike KPI, even on a DMG or a Grob machine, or on our own tool control center, is always called spike and spike polar. Because even DMG, or we don't want to, as partners, confuse the end consumer and make sure he knows what's inside, which philosophy is he using. And it doesn't matter which tool he uses, as long as he understands the philosophy, and that is the one of spike. And these are the benefits that you actually get. based on this BLISC, a quality report per component, which you can give to your customer and say, I can give 100% automated documented quality report in the way with the spike map that we've seen earlier. You can visualize the whole operation extremely easily, which makes it easier for all of us to understand what's going on. The reaction in the machine, change the resistor tool, eject the component, have it sent to a separate testing session. Not all of them, just the ones where you're really insecure. You identify chatter, blade break detection, or of course, determine the surface quality. All of this during production. That's why these were different use cases that we saw early on in the BLISC, or in the form in the car, or in a component within, for instance, a CNC machine that we saw earlier. And this is the picture when we're doing the form. So you saw at the end, when it turned red, and this was obviously a workpiece where you only make one of. When it turns red, there is something wrong. You need to look at your CAM program. And what about the next step in integrating that with your CAM program automatically? But I shouldn't say too much at this stage. So, process monitoring, tool breakage, tool wear, which we can see. So easy yes and no decisions, more complicated decisions on tool wear. Process errors, which one was good, which one was not so good. Spike KPIs based on the individual cutting edge status. And then using the spike KPIs, for instance, for vibration and chatters. And all of these you can use as parameters for your selection on the visualization of the spike map. So not just the bending moment, but also the spike KPI or a combination of them. Whatever you think is the perfect way of documenting your workpiece quality 100%. Now, this is the basis of a lot of data. And we all know, and Volker Kreidler, that speaks after me, will be able to pick up on that much better than I can. To be able to have data, you need, or have the benefit of artificial intelligence, you need a lot of data and you need good data. So if we have the number of measurements trained on this action and the quality of the data, the exactness of it on that axis, Spike can see these sort of differences. Less good can be seen, but still seen others. And if you don't have any good data and you can't see the difference between good or bad, worn or not worn, you're not going to be able to use KI. And data is the quality for KI-based learning. And Spike, we think, helps us to move us into that corner on the top left to be able to have the type of data that you can do most with. And this is an example we did a drilling process, only 100 drilling processes, and looked at what are the typical errors that you might occur in these drilling processes. A cooling error, a chip removal error, a run-out error, a run-in error, or a wear error. And we managed to find, with quite a high probability, 90% of all cases, which errors had occurred. Now, that's only the beginning, and Volker Kreidler from Big Data Manufacturing can tell you much more what you can do if you use the right solution with the right intelligence. To summarize, I would like you to remember that with Spike, you see the individual cutting edge. With Spike, you can do different quality of process monitoring, from just yes-no answers to very complicated answers. You can turn those into machine legible values, the Spike KPIs, with a connection to the machine PLC. And you can visualize all of these for 100% workpiece documented quality control on the Spike map to get a perfect part every time, and to allow 100% inline product testing or quality control every time. Why? Because, yes, we would like to set, sounds ambitious, the global standard in digital machining. Can we do it alone? Of course we can't. We would like to do it together with you, our partners in the value chain, and that's how we can set a global standard from Germany, from the PTW in Darmstadt, from Bavaria, I have to say it, and from Europe for the whole world. You know, other people are doing this, other countries are doing it. There are many areas where we in Europe have lost that standard. The industrial manufacturing process, that's where we can set that standard in digital machining. Let's do it together. Thank you very much.
Thank you, Mr. von Zastrow. So, who has the first question for Mr. von Zastrow? It's Petre Koller from Prague University. Petre.
Thank you. Thank you for impressive presentation. I would like to ask you to your perspective. Of course, you produce and sell the sensory tool holders, but many other research teams works on sensory machine tools. So to get data from the machine tool and for the same purpose, yeah, to understand behavior of the process itself. Your sensory tool holder is more sensitive, has some advantages comparing just to the machine tool approach. Could you comment a little bit your perspective or your opinion in this way? How do you see the movement on the market in this topic? So sensory tool, machine tools and sensory tool holders. Thank you.
Very good question. I'm grateful. We decided to put the Spike, which we started with the sensory tool holder, into the spindle, because we knew that you have to be in the spindle in the machine to set the standard. In my view, 50% of the market of all processes will be controlled in this way, and 1, 2, or 3% will be supported by Spike Mobile in the sensory tool holder. But Spike in spindle, as the integrated solution that you can use in any process, roughing, finishing, wherever you think is important. Also to take autonomous machine action is the basis for that. But if you have an existing machine, why not use, and we do that also together with partners, the current of the motor extract as much data as you can from the machine, but where you really need the type of data that I was speaking about, the individual cutting-edge based data, Spike data, combine it with a tool holder, with Spike Mobile. We have 24/7 operations in several countries with Spike Mobile because there is no other way of doing it. But of course, the next time this customer is going to buy Spike and Spindle and combine Spike and Spindle with a Spike Mobile where he needs to.
Thank you. Other questions for Mr. von Zastrow? Ebert Abele.
Well, first, thanks of all, Mr. von Zastrow, for this excellent presentation. Very clear. In the real life, in a manufacturing plant, you have some, let's say, some influences which depends on the workers inside such a line. For instance, one body sets the override a little bit higher. One person may change the fluids, the lubricants in the machining shop. What about your experiences with all these influences in the real life?
That's why, thank you for that question too, because that's why I believe so strongly in working together in the value chain. We have a technology transfer center in our office in Kaufbeuren, where we have Grob, DMG, Tertizid, Göring, Blaser, people like that to work together on use cases to experience exactly that. One thing where we, for instance, measure the effects of changed liquids on the process, and how can we see them in the Spike. We started with Spike and pro-micron in delivering sensory tool holder as diagnosis systems to all these companies in the value chain to improve their cooling liquids, to improve their tool design and so on. This pays up now because we can be more sensitive towards changing parameters like that. The first thing is that we identify something is not like it should be. If you, for instance, use the sensory equipment by liquid tools that measures the viscosity and the pH values all the time, permanently, and we can combine that within our tool control center, we can put it into the algorithms. And why not also give that to big data manufacturing to use it in the artificial intelligence algorithms? That's why I think if we try and set the standard by ourselves, we'll never succeed. But we can succeed if we work extremely fast. And it's something that's really at my heart, because I think it's going to change the machining world. I think a lot of boring jobs will go in this machining world. A lot of those people's jobs will go, of which we don't have enough anyway, of those people. But new jobs will come, and those will be less do the same every time, but do more project work on all levels. That means we have to actually lead these people totally differently, or we have to be led totally differently. Because you have to look outside the day-to-day task, and you also have to be allowed to make errors. That's going to be a change driven by digital machining, and I think we need to prepare our students, like you do, our workers, our employees, to be able to see that as an opportunity.
So, thanks again, Hubertus von Zastrow, for this really interesting keynote speech. And we see more in the evening event at our Tech Lab. Thanks.
Thank you.